4.1 objectives. Number 1, evaluate exponential functions. Number 2, graph exponential functions. Number 3, evaluate functions with base e and use compound interest formulas. Okay? So before we evaluate exponential functions, can I remind you what evaluating a regular function means? Is that okay? So if I say f of x equals 2x plus 5, and I ask for f of 3, what do I want you to do? Yeah, anywhere there's an x, I want you to put in a 3, right? So I want you to say 2 times, well, if we're doing f of 3, we're going to say 2 times 3 plus 5. Well, what is 2 times 3? 6 plus 5? 11. So f of 3 equals 11. Does that make sense? So if I'm asking you to evaluate exponential functions, all I'm asking you to do is 2 to the x plus 5 and find f of 3. So anywhere there's an x, I'm asking you to put in a 3. So 2 to the third plus 5. Well, 2 to the third is 2 times 2 times 2, which is 8. What's 8 plus 5? 13. So f of 3 is 13. Does that make sense? What about if I ask for f of x is 3.5 times 2.3 to the x? And then I ask for f of 4. Is that any different? No? Do you happen to know what 2.3 to the 4th power is? Yeah, me neither. Okay, so then that's where I would get my calculator. And I would say 3.5. You can't see that. 3.5 times 2.3 raised to the 4th power. So 97.9, let's see, f of 4 was 97.9444. And just depending on how many decimals it asks you to round to, yeah. Thousands, hundredths, 10,000ths, whatever it asks for. Yes? Okay. Any questions about evaluating functions? Can we skip to number 3 real quick? Because isn't that kind of asking the same kind of thing? Okay. The only difference is it's going to say something like f of x equals 4e to the 5x power. Well, I need you to remember something about e. Okay. E is approximately equal to 2.71828 ... right? It is an irrational number. Which means what about it? Irrational means I cannot write it as a fraction, right? Okay. So it goes on, never repeats, just like pi, right? Exactly. Okay. So the only difference between these ones that I showed you already and this one is that it literally just has an e in it. So for sure we're going to have to use our calculator in this because I don't know what 2.71828 to any power is except 1 and 0. You know what I'm saying? Okay. So if I ask for f of 2, I'm going to write this out just a little bit more than we did up there just to make sure. This is really 4e to the 5 times 2 power, right? So I could just put in my calculator. Oh, make sure that we're using the right e here as well. Okay. There's 2 places you can get it. The easiest place is right here. Okay. Please do not use this e. It's not the same e. Okay. It's also here under the pi key, but if you use the e under the pi key, then you have to raise it to the power. This e already raises it to the power. Does that make sense? And if I can either put 5 times 2 or I can just put straight in 10, right? F of 2 would be 88,105.9. It's probably approximately that, isn't it? because I already know e is an irrational number, and if I'm raising it to the 10th power, it's not going to automatically become a decimal like that, a nice pretty decimal, right? That's probably a rounded number from my calculator. Okay? You okay with that? Because like I said, it's just the same as these up here. It just has an e in it. So we have to make sure that we're using the right button on our calculator, this e value right here. Okay? Number 2, graph exponential functions. Well, this is good news, right? Graphing exponential functions. Here's what I need you to remember. Okay? I need you to remember that I just drew on myself when I tried to put the lid on. F of x equals 2 to the x. Is that the parent function for exponential? Or is it a parent function? It's a parent function, right? Exponentials are different than like linears or quadratics, because linears and quadratics, they have one parent function. That's it. Okay? Exponentials have multiple parent functions. It could be 2 to the x, it could be 3 to the x, it could be 5 to the x, it could be 10 to the x. This base just gives it its shape. Having an x in the exponent and only an x, that makes it a parent, right? Okay, so this is a parent. Draw it for you real quick with my amazing graphing skills. Why did I make sure it goes through 1? Why did I make sure about that? Because if x is 0, what's y? 2 to the 0 power is 1, right? So 0, 1, that graph right here definitely goes through that base, doesn't it? Okay? But what if it was this? F of x equals 1/2 to the x, because isn't that a parent function? Yeah, nothing's being added, subtracted, multiplied, or divided to that variable, right? This looks more like this one, right? That's this one right here, and this one is this one right here. So we know that this first one is called exponential what? Because from left to right, it is growing. So exponential growth. So which one's this called? Absolutely. When I try to answer when I'm spelling exponential, I always spell it wrong, so sorry about that. So growth, what makes something growth? If the base is, we'll call it b, if b is greater than 1. That's what makes it growth, right? What makes it decay? If it's less than 1 or greater than 0. Right? We don't care about negatives. Negatives does something different to the graph, doesn't it? Which brings us to our next point. Let's get this out of the way first. This is the base. That's not a variable. That's just a letter we're using to represent the base. Okay? What does the negative in front of this equation cause if we're graphing an exponential function? It causes a reflection. Or a flip, right? A reflection over the x-axis. What does the A cause to happen? A vertical what? A multiplier. So a multiplier causes a shrink or stretch, right? Sometimes instead of saying shrink, we say compression, but those are the same thing, right? Okay. What about the H? What does the H cause? Horizontal shift. And what's the most important part of that word? The F, right? We have to remember our F's. Those are important. And what about the K? A vertical shift. Again, the F is important. Okay? So, for example, I don't want to scoot that up too far. F of x equals negative 4 times 1/2 to the x plus 3 power minus 2. Tell me all the things that change. Well, first of all, tell me the parent. Can you tell me the parent? So the parent is f of x equals 1/2 to the x power, right? That's the parent. So anything else, I have to figure out what it does. Okay? So what does this do? Okay. Reflection over the x-axis. What's the 4 do? Good. Vertical stretch by a factor of 4. What about the 3? It is horizontal. Why? So horizontal shift, left 3. Because we know that's the thing that's inside the exponent, right? And when it's inside, it moves different of what we think it should move. We think it should move to the right because it says plus 3. We know it should be different than that, so we know it's left 3. Okay? And then what about this? So vertical shift. Down 2. Now, I do have to go back up to the top because I did forget something. Can I fix that real quick? Okay. What if there's a negative in front of the x in the exponent? What does that cause? Reflection over the y-axis. And what if there's a multiplier in front of the x? Let's call it, I don't know, j. What does the j cause to happen? It's a horizontal stretch or shrink. But remember, it's different than what you think, right? Right here, this is a 4. This is a vertical stretch or shrink because it's outside, so we know it's vertical, and it's greater than 1, so we know it's a stretch, right? If the 4 was right here where the j is, that would be a horizontal shrink because it's different than what we think it should be, right? Does that make sense? Okay. That's not usually j, that's usually the b, but we have b standing for base right there, so I just made up a j. Okay. Any questions about this? Any questions so far about any of our objectives 1, 2, and 3 that we've talked about? We good? Okay. Then last, what we have to talk about is compound interest formula. Okay. I don't know what I actually said when I meant to say was compound interest formulas. My tongue got a little tangled there. Okay. So I'm going to remind you of the two that we use. Okay. A equals P 1 plus R over N to the NT power. And A equals P E to the RT power. We use this interest formula when it's compounded a certain number of times that's specified in the formula. It could be, or in the sentence. It could be monthly, which would be 12. It could be weekly, which would be 52. It could be daily, which would be 365. What else could it be? So I'm like annually, which would be what? How many times per year is annually? 1, yeah. Okay, but it'll specify that in the words of the problem. Does that make sense? So which one is this? That one's compounded continuously. This is the formula we'll use if the words in the problem say compounded continuously. But just to make sure we remember, what does A stand for in both formulas? What does A stand for? It's the amount we end with. Okay? Well, then what's P stand for? It's the principal or the amount we start with. What else do we need to know? R? What's R? It's the interest rate. Remember, it's given in a percent. So, for example, if it says 12%, what do we put in the formula? 0.12, right? If it says 8%, what do we put in the formula? 0.08, yeah. Two more variables that are here. What do we need to know? N. N is the number of times it's compounded. And I'm going to put an asterisk by that because I just showed you what those were right up there. Does that make sense? And the last variable you need to remember is T. And what does T stand for? Because that's what it typically stands for, right? Time. We need to make sure to always know that this is time in years. So if it says 6 months, what are we going to put in? 0.5, yeah. Or a half, yeah. Okay? Do you remember these formulas? Good? Okay. Do you have any questions about our objectives for today? Do you feel prepared to do problems on each one of these 4 objectives? Good? Good.